Hello, everyone, and welcome to the Wilson Center. We have a fascinating discussion ahead of us today. And to kick us off, it's my pleasure to introduce the President and CEO of the Wilson Center, Ambassador Mark Green. Now, when Congress established the Wilson Center, it was centrally located here between the executive and the legislative branch. And I think that in Mark Green, we have someone who actually epitomizes exactly what Congress was getting at. After all, former congressman from Wisconsin, 8th District, right? Okay. And also someone who has worked as part of the executive branch as the head of USAID and as ambassador to Tanzania. So when you put that all together, he is also the living embodiment of the ideals of the Wilson Center, which is to make sure that we are providing informed and scholarly analysis and that touches on the issues of the day, and the policy recommendations that we make are actionable and of use to people who are addressing the challenges we face. So with that, and without any further ado, Ambassador Green.
Thanks, Robin. And let me add my own word of thanks to all of you, those who are here in person, impressive audience, as well as our virtual audience from around the U.S. and around the world. So something that Robin was alluding to, for those of you who are new to the Wilson Center, we were actually established by Congress 5 decades ago for the purpose, in their words, of strengthening the fruitful relation between the world of learning and the world of public affairs. So what that really means is that while many other institutions deal in data and information, Congress asked us to go further into scholarship and learning. And so our currency is knowledge, our focus is independent analysis, and our mission is developing options and recommendations that decision makers can believe in. And we are fiercely nonpartisan. We have world-class research programs dedicated to nearly every region of the world. And we have world-class programs dedicated to critically important challenges and opportunities, the policy areas that I think will shape the future and America's role in that future. In a matter of weeks, for example, we'll be launching an exciting new initiative on America's strategic leadership in a very competitive world, with a special focus on critical infrastructure, innovation, commerce, and diplomacy. All of that makes this a perfect place for today's discussion. And as we gather today, and we begin today, we all owe a special debt of gratitude to Harman International for co-sponsoring this event, but also for their many contributions to our understanding of innovative infrastructure and intelligent transportation. These are the kinds of partnerships and collaborations that have accelerated work on 5G and V2X. Today's event brings together speakers from across the automotive and mobile communications industries to discuss examples of highest and best uses, opportunities for economic development and growth in these sectors, and also the regulatory obstacles that perhaps hold some of this innovation back. We'll also look at the implications of these technologies for global competition, national security, and the intelligent transportation systems that the Biden administration is promoting. To set the stage for this conversation, we are fortunate to have a special guest, Congresswoman Debbie Dingell. As the saying goes in politics and public policy, there are 2 types of members, show horses and workhorses. She's been a workhorse for a very long time, inside government, outside of government, on a range of crucial issues that really do matter to the world's future and America's leadership. These days, she serves on both the Committee on Energy and Commerce and the Committee on Natural Resources. Her committee leadership roles cover critical subjects like 5G, smart transportation, communications, and the implications of Buy America. So we are very lucky to have her with us today, and even more fortunate to have her in Congress these days. Debbie, I'm delighted to have you, and thank you so much.
Good afternoon, everybody. Thank you to Ambassador Green, who comes from my neighboring state of Michigan. We did beat you in football this year. but it won't mean quite as much as the Ohio State game will in 2 weeks. But I want to thank you for that kind introduction, and I'm very glad to be at the Wilson Center, and to have Wilson invite me for this conversation. I think the work that is done here is so important, and we need to be bringing people together for more of these kinds of conversations, and in a nonpartisan or bipartisan way. So, and it's great to be here with so many leaders and experts, because this will be a great conversation, and it really is one of the most important, competitive, and innovative conversations we have to have in this country right now. For those of you who know me, like John, who's known me forever, I'm a car girl, and I've always been. This discussion is important to me. I worked for the industry from Southeast Michigan, and quite frankly, it just has driven me all my life. That wasn't an intended pun either. The auto industry is really at an inflection point right now. We're at a critical time to decide a lot of key technology questions. We've got to decide where, how, and by whom electric vehicles are going to be built. I'm excited about our country's opportunity to herald a new era of mobility and sustain our role as a global leader in auto innovation and manufacturing. Automobiles and commercial trucks are becoming safer, smarter, and cleaner, creating that new era of mobility. And we need to ensure that we, as lawmakers in the public policy field, are meeting that moment. Quite frankly, I think we're dragging our feet too much. So I want to talk to you today about some of the work we're doing to make sure policy is keeping up with industry innovations and supporting auto manufacturers, consumers, and everyone in between. Our country has already taken a critical step forward by setting new standards that will help ensure our national EV charging network is user-friendly, reliable, and accessible to all Americans. EVs aren't going to work unless we have a charging infrastructure. The bipartisan infrastructure law includes historic investments of $7.5 billion for EV charging infrastructure across the country, and more than $7 billion for the critical minerals supply chains necessary for batteries, components, materials, and recycling. And I'll tell you, that's one of the most important discussions we've got to have. We cannot be 80% dependent upon China. We've got to bring in, and we are putting together, John knows this, that when we started talking about EV goals for this country, I was someone who did not sign on to the Green New Deal because labor wasn't at the table. And all the partners had to be at the table. So we brought together a table of all the CEO of every environmental group was at the first meeting, and the CEOs of the unions. And we worked for months, and it resulted, the OEMs were there when we made this announcement at the White House a year ago of a goal when they listened to each other. We have to do the same thing on batteries. We have to figure out a way that we are going to mine those minerals, develop new minerals, and that's probably one of the most important things that we've got to do in this. And Jared Huffman in the environmentalists and unions and a lot more people that wanted to be involved the last time want to be involved this time, but it's those kinds of discussions that will get us where we need to go. We're also working to bring down the cost of EVs to make sure this isn't just one that if you can afford. I was in a UAW hall 2 weeks ago and a woman yelled, "And I don't want to drive an electric vehicle," because she didn't have a garage and didn't think she could afford it. We have to address all of those issues. It needs to be available to everyone. We included a series of consumer tax credits in the Inflation Reduction Act, including a clean vehicle credit, previously owned vehicle credit, and an extension of the federal income tax credit on alternative fuel vehicle refueling property for another 10 years, which would bring down the cost of electric vehicles, making them affordable and accessible to more Americans. The Advanced Manufacturing Production Credit in the IRA will also make tax credits available to manufacturers for the production of electrode active materials, battery cells, battery modules, and applicable critical minerals, savings that can be then passed along to the consumer, and the autos know, I'm hoping, it will be passed along to the consumer. We must continue to invest in research and development to pursue the innovations that are driving the future of this industry. That's why I recently reintroduced my Vehicle Innovation Act that reauthorizes DOE to work with manufacturers and suppliers to research, develop, and deploy advanced vehicle technologies that improve energy efficiency. I also teamed up with Haley Stevens from my state on the Shifting Forward Vehicle Technologies Research and Development Act. This legislation makes significant investments in transformational mobility technologies, R&D, to reduce our transportation carbon footprint and ensure America competes while increasing domestic production and decreasing the cost of vehicles, advanced batteries, and hydrogen fuel cell manufacturing. The American auto industry has made major advancements in fuel efficiency technologies in the last decade, and we've got to work together to ensure that we continue to lead the world in vehicle innovation as we make this very critical shift towards a clean economy. And look, I don't care, global climate's real, and we are 30% of carbon emissions. So we have to work together. It's where we're going, and all the OEMs are committed to that, quite frankly. And I say that to people. Finally, we can't talk about the future of transportation without addressing the importance of autonomous vehicle technology and the policy changes we face when discussing vehicles of the future. If the United States is going to stay at the forefront of innovation, manufacturing, and safety, we have to make sure that our nation is engaging all stakeholders, making bold investments, and working across the aisle. I am so totally committed. I'm losing my best friend in Fred Upton, but I'm going to still have some on the other side. That doesn't even sound right. We're going to work in a bipartisan way to get the necessary policies right to support the safe deployment of autonomous vehicles and other automobile policy. Last August, I launched the Bipartisan Autonomous Vehicle Caucus with my friend Bob Latta from Ohio, who's another Republican, who I work with very closely in all these issues as well. This caucus will provide a space for members to learn, discuss, and collaborate on all the important issues and opportunities related to autonomous vehicles. Because the future of American mobility and leadership depends on us getting it right and working together. And by the way, we can't get any further behind. Supporting and strengthening the auto industry, from ensuring legacy companies are not left behind as the landscape continues to evolve, to investing in innovation and development, will always be one of my number one focuses. I look forward to the continuing work of all of you and continuing this very critical dialogue. Thank you for being here.
Good afternoon. Thank you for joining us today. My name is John Bozzella. I'm the president and CEO of Alliance for Automotive Innovation. We are an organization representing auto manufacturers, technology companies, new entrants to the mobility space, all dedicated to cutting-edge technology that makes vehicles and personal transportation cleaner, safer, and smarter. I want to thank Ambassador Green and the Wilson Center for hosting this discussion today, and for Harman International and their support for this discussion. It's critically important. I also want to thank Congresswoman Dingell for your remarks. I have known Congresswoman Dingell a long time, and I can tell you, when it comes to the automotive industry, the workers of this industry and the communities that operate in which it operates, there is no greater champion and no harder worker than Congresswoman Dingell. Thank you for what you do for the industry, both as it is and as it's becoming. So we very much appreciate your remarks today. Thank you. Today we're talking about intelligent transportation, and we're talking about the systems and technologies that enable it. And we're talking specifically about wireless technology. I want you to take a ride with me. Imagine that we're in a car, and imagine that this car can communicate wirelessly in tenths of a second with other cars. Imagine it could literally see around corners to save lives and to make personal mobility safer, cleaner, more efficient. Imagine that that were the case. Imagine you were in that vehicle. That technology exists today. It's called V2X, vehicle to everything technology. It's pretty cool stuff, right? If you think about it, right? The ability for vehicles to communicate where they're going, what speed they're at, and for another vehicle to accept that communication and understand in physical space what to do about a potential collision, or what to do about loading a highway more efficiently, or what to do about providing information that could benefit first responders. This is the type of technology that we're talking about today. Is it available on public roads? Not quite here in the United States. Is it available on public roads elsewhere? Yes, maybe to a larger degree. So if this technology is available today and it can save lives, what's holding us back? And what can we do to accelerate this technology if in fact it can deliver the promise that I just outlined? These are some of the questions that we're going to discuss today with an all-star panel. I've been around this issue for a long time, and I can tell you we're going to learn a great deal today. And let me just briefly introduce them, and then I'm going to just get right into it. So we have Ramswamy Iyer, who is the Senior Vice President of Connectivity at Harman International. Ram, thanks for being here. We have Ambassador Mark Lippert, who is the Executive Vice President and Head of Government Affairs at Samsung North America. Mark, thank you. Jonathan Weinberger from General Motors is the Chief Advocate of Global Transportation Technology. And also we have Robin Quinville, who's the Director of Global Europe Program at the Wilson Center. Really terrific panel. Let's get right into it if we can. I want to start with you, Mark. How are companies like Samsung building the foundation for the realization of this mobility technology? Where do we start? What's the foundation for this?
Well, thanks. Great honor to be here. You're right, it is an all-star panel. I am, I think, the pinch hitter or maybe the number 9 hole hitter here and the least expert in this field. But what I would say, I think it does show how important, how critical this issue has become, not just here in the United States, but also in my former life as U.S. Ambassador to the Republic of Korea. This is central to the alliance right now, and that's what President Biden, President Yoon Suk-yeol were talking about this weekend, along with Japanese counterparts. So it's not just the U.S., it's global. But back at home, to your question, I think where Samsung could be focused, at least part of the Samsung group. Get the mic right. All right, there we go. Well, it says don't adjust the mics on the bottom here, so I was I took that literally. So the first of all, I would just say, Samsung's a big group, right? And we have one element that is very focused on what Congressman Dingell was talking about in batteries, right? But another part that I want to talk about quickly is 5G, right? To your point about imagine this world and taking this drive, that becomes possible the more 5G is integrated into the backbone, right? It is just to Congressman Dingell's analogy of the charging stations, the analogous is 5G, right? You have the charging stations, you have 5G, that helps integrate into this sort of intelligent transportation design and make that a reality, right? And I think as a company, I'm new to it, but I've been around it for years in previous lifetimes. I think where Samsung really did make a huge investment was on the millimeter wave radio piece, right? Took a part of the spectrum, underutilized, and really started to basically put that into play in the 5G basically nexus, if you will, to allow us to basically be connected faster, more quickly, low latency rates, all of that good stuff. So what do we need to do more of? I mean, look, it's to help build this backbone is we need more public-private partnerships, we need more market mechanisms, we need more of the structural tools that enable the 5G backbone and 6G down the line that will unlock the great technologies that all of you all have been working on as an industry. Let me just stop there.
Yeah, thank you, Mark, for that. Before I go to Jonathan, I just want to follow up a little bit about your point about collaboration and partnerships. Samsung certainly has a number of those, and in the 5G space, right? I mean, you've got, maybe help us understand that a little bit more. What do those partnerships look like? I read something recently about Samsung and Dish, for example, and others, where you're building out specific sort of 5G related work. What does that look like?
Well, I did take some notes with me because I'm new to the company, and so I have them handy here. But first, world's first commercial 5G network with Verizon in 2018, right? Subsequent 5G deployment projects with AT&T, U.S. Cellular, Dish, and Comcast, as you rightly note, John. And then outside the U.S., right, partners with other top-tier operators, Korea, Japan, India, and Europe. And I'd be remiss if we didn't talk about all of our good work we do with our friends with Harman, right? And basically 5G-enabled cockpits, all of that good stuff. We do have a lot of different partners in this space, and we do consider two-way collaboration essential to the mission.
Got it. So, Jonathan, let's now apply this to the automotive industry. What is 5G? And you can look maybe specifically at CV2X or V2X, and then maybe broaden it a little bit. But what is this revolution in intelligent transportation technology mean to General Motors?
That's a great question, and thank you, the Wilson Center, for having us here. I think it's such an important conversation, and so glad you could moderate it. I feel like we're a good panel team. When you mentioned the all-star panel, I was thinking, yeah, and me. But no, that's a great question. I mean, I think it's existential, really, not only to GM but other OEMs. You hear announcements from GM and Stellantis and Ford and other companies about the new type of revenue streams that we're going to have to generate over the next couple decades as we transition from ICE to EVs. That digital stream, the digital cockpit, and the new infrastructure that we built a new infrastructure called Ultify, and it's built on another sort of the nervous system called VIP, and that VIP could process 4.5 terabytes of data per hour, which is about 5 times what we have now. So if you think about that, and then on top of that VIP, we built Ultify. And that Ultify, if you think of it like your iPhone, where you could download apps, there's an app store. Some of them are open source for developers. Developers could develop certain things that you go on the GM store and you could download onto your car. They could be over-the-air updates. So all this infrastructure and system and connectivity is so important. Just to take a step back and go down this road, we tried in 2017, we had about, I think it was like 22,000 CTSs with V2V technology, just to test it on the road. It was a very successful program. One of the issues was only CTSs could talk to other CTSs, and they could tell the other CTS, hey, there's a pothole, there's an obstacle, there's a crash, whatever. Very successful program. It lasted for a couple years, and then it ended. There's not enough public-private partnerships with the FCC or whomever to make it sustainable. We need those private-public partnerships. We tried to use the 5.9 gigahertz spectrum, which we all knew too well. We sat on that spectrum for decades while we were developing it. It was then reallocated to the Wi-Fi world, which did not help us. So we're looking at 5G and other connected ways to figure out how to develop this system, develop Ultify, develop VIP, and move it into the future in order to create a better environment for the driver, for the passengers, for the consumers. It makes your life better. It makes your life easier, just like your phone. I mean, you know how addicted you are to your phone and all the conveniences that all those apps and what that brings you. We see that in the car. And if you think about it, you mentioned when we were talking earlier, there'll be this mix of different cars, AVs, EVs, ICE, for the next 50 years or whatever. If we have the capability to use Ultify and VIP to do over-the-air updates, the car, usually when you buy a car now, it's the best it's ever going to be, day one. Now, overlay this type of technology, the car gets better. The car gets more useful. The car gets safer. It gets faster. If you want to download a program to make it quicker, you could do that. So the car becomes more and more valuable to you, and maybe you keep it, the average age now is 12, maybe you keep it longer. So that's a lot of stuff, but it shows how important it is to us and other OEMs.
Yeah, really, there's so much in that, right? You talked about creating this environment for innovation, right? A vehicle-based app store, for lack of a better term, that's driving innovation, right? Enabled by 5G. Also, you talked a little bit about, sort of your experiment, General Motors' experiment, the Cadillac CTS, actually in the marketplace, on the public roads, with vehicle-to-vehicle technology. On roads now, there's been a little bit of a shift of policy, right? And maybe a shift of technology from the platform you were working with to platform that's likely going to be used going forward. And I want to bring you in, Ram, now sort of on that. What I heard Jonathan say was, hey, we at General Motors, we experimented with this very idea, vehicle-to-vehicle technology with a certain technology platform and a certain set of vehicles. What do you think worked about that experiment, and what do we need to be doing to accelerate more of those types of deployments?
Sure. And by the way, it's an honor as well to be here at the Wilson Center and represent Harman. When you look at these technologies in an ideal landscape, you have them all, at once. So when you talk about 5G and V2X, and V2X being DSRC, C-V2X, it's much easier to do these things when it's done in a smaller scale, right? So when you have the different cars talking to each other in a common language, and it actually works, right? Where it fails is in reality, the landscape is not that ideal, right? So you have cars of different capabilities, and you need to start thinking about how do we plan scale in a gradual manner, right? So you need to start small, and you need to see and how do we plan for this kind of diversity, while on other front, we have to plan for success and on how that ideal landscape would actually operate. And then create these baby steps from where we can be today in order for cars with different capabilities to talk to each other. So for example, how would a non-V2X vehicle talk to a V2X vehicle? Is there some kind of a common platform or a denominator that really can bridge these cars, right? Leading to a landscape where literally the two cars can talk the same language. And this is where we actually at Harman are building out some kind of an alert framework which can notify cars using the mobile technologies, given that most cars will have some kind of a mobile technology, either in the form of a phone or the car themselves are connected. But these are basically a great starting point for how we can deploy alerts to almost all the cars. So think about it, like if you're on a road and you have a glare, or you might be heading to a location which has pretty bad conditions. And these are going to be catastrophic. And you can be alerted proactively about these situations, right? And of course, in an ideal world, as I said, in C-V2X, the cars are going to communicate this right between each other sequentially. But then if you have to start that today, we can still use certain technologies like mobile technologies to communicate the same message. So my perspective is that we have to start today in whatever scale possible, while we still plan for those successful scenarios and an ideal landscape, and then figure out how do we really go from the step 0 to step where we can actually meet that ideal landscape, I would say.
Yeah, so for folks who are following along, let's just make sure we're clear. When you're talking about alerts, for example, this would be over a basic cellular network
That is correct.
would provide important information to a driver or to a pedestrian or to a bicyclist, on a cellular platform.
Yeah, I mean, yeah.
Right? And I'm sorry, go ahead.
Now, the framework is called as a vulnerable road user,
Right.
And VRU, which is pretty popular in the safety and transportation world. And precisely this is about using the VRU framework and saying how to alert a common man who is actually on the road with alerts on their mobile phone. And the same in a user, when they step into the vehicle, they get the same alerts either through the vehicle integration systems or through their same mobile phones. But one way or the other, you're going to still be informed about these alerts.
Right. And so that's a building block toward this lower latency, immediate vehicle to vehicle or vehicle to infrastructure communication, right? Just so we're distinguishing between the two of them, right?
Absolutely.
So we start now with this opportunity to provide more information, more alerts, cover more road users, and then build toward a low latency type of communication that could be integrated, for example, into crash avoidance systems.
Absolutely. I mean, create that critical mass, right? I mean, the success of these technologies is only when you have the critical mass in it, right?
Yes.
And so the only way to do that is to build that common framework. Now, of course, the latencies may not be ideal on a 4G network, but the moment you move on to a 5G network, the latency problems actually become a lot more better, right? And then when you bring in the CV2X, it gets even more better. So how do we basically scale these services according to the capability of your environment, the network, and the vehicle? You can actually auto-scale these services according to the network availability.
Fascinating. I want to just ask you one follow-up question to that, which will, I think, transition nicely into a question I have for Robin. How would you compare where the United States is with regard to these types of technologies, alert systems and vehicle-to-vehicle or V2X technologies deployed with what might be happening, say, in the EU or in China or other parts of Asia?
Yeah, as we were just talking right before this, it's interesting that US, which started pretty much like the research in this area, 20 or maybe even a bit more than that, we are still not at scale compared to where the other regions are. And if you look at EU, for example, they have the same debate between DSRC. There's a specific OEM that actually vouches for that, while the others are still playing the CV2X card. So that debate continues. While maybe in China, they're going down the path of CV2X, while they started off research as well using the DSRC. So if you look at all these things, and then what is it that they are doing additionally to boost this adoption? I would say that's NCAP, right? And for those who are not familiar, NCAP is like New Car Assessment Program, and that's a framework that people use to drive commercial attractiveness for why a consumer would go up and buy a car. And they're trying to say, if you, in order for you to get a 5-star rating on an NCAP, you have to add the V2X technology, right? And they're doing that in the 2025 to 26 timeframe. I mean, that timeline keeps moving in Europe, while in China, they want to do that faster. And so it starts with the EU NCAP, and then that culminating into a CNCAP, which is kind of like advancing it more from a timeline perspective, but they're both driving the adoption in that manner. Here in the US, I think we are still keeping that debate open between the technology, and then the commercial attractiveness model is somewhat falling behind. And so easily you can see that while we are far ahead when it comes to data and research, we're still not there when it comes to commercialization and scaling these things.
Interesting. So, Robin, cutting edge technology, US leadership, yet maybe we're falling behind. So, how should we think about this from an international economic competition point of view?
Well, thanks very much. I'm still loving the idea of a car that accrues value and gets better over time. You'll see in my bio that my last job before I left the State Department was as chargé d'affaires in Berlin, so that's acting ambassador. And it's fair to say that in Germany, the relationship between you and your car is, absolutely fundamental. With that, I think that they see, and because this is such an important industry, they and other countries in the EU see that this development of technology is absolutely critical to global competitiveness. It is not simply for the German market. These are global companies, and often manufacturing in places like China. The debate that I think they will have is, are we going to be a rule taker or a rule maker? And when you are talking about an entity, the European Union, that functions on putting it together regulations that bind the member states together, then you will find yourself in the position of trying to ensure, as Europe, that you are competitive because you are a standard setter. And I think this is perhaps the economic challenge we face. And they will not want to be a rule taker from the Chinese perspective, even though they will be manufacturing cars in China to a very high degree and for that market. I think they also see it not just in terms of the global competitiveness of European companies and the need for that and the need to be the standard setter, but also from a perspective of how they are going to implement their own climate change goals, because they see the automotive industry and this kind of technology as part and parcel of how they are going to reach their aims on their own Green Deal and reduce emissions. If you are having a system where you're integrating what you're doing on the roads with what you are doing on rail, on waterways, on other means of getting things around to be maximally efficient and reduce emissions by, their aim is to reduce them 90%. That's a lot. But they see that if they can do this and do this smart technology, it will not only increase the attractiveness of their brands, but also the competitiveness of them as a climate change maker as well.
So I want to take it one step further. I love this idea of rule makers and rule takers, and how that relates to technology leadership. I think that's fascinating, and I can really identify with it and relate to it. What about the national security implications of this type of technology, 5G-based intelligent transportation technologies? Are there national security implications we should think about?
Well, this is where I'm going to be perhaps the most downbeat person up here, right? But it's only because I'm challenging y'all to solve this problem before we have it, okay? So I'm going to do two things. First, one of the things that I think we will have to watch out for as we work with our European partners, and let's face it, don't we really want to do that so that we have more synergy together, is to say, right, let's ensure that we don't run afoul of data privacy regulations, because those will be challenged in courts and so forth. So let's make sure that what we are doing is not seen as undermining the data privacy that is so important to many of our European partners. Second, let's keep in mind the vulnerability to cyber attack. And a reminder to everybody, there's military mobility too that's involved here. And we need to make sure that we are able to move on that front as well. But on cyber attack, we've seen a lot of cyber attacks on governments and denial of service and so forth and so on. But there have been some that have specifically targeted in transportation infrastructure, and that includes railways and airports and so forth. And there was one in Lithuania in June of 22. In February of this year, there were some oil terminals targeted, and that meant that ports could not offload, and this meant shortages and so forth. And in October, not that long ago, in Germany, the rail system was thrown into utter chaos by a communications attack. And Deutsche Bahn, the German railway system, accused, the Kremlin. And that's kind of a big deal for a German company to do. But policymakers were also very wary of this, and were really looking at, okay, we need to invest to ensure that we are protecting this critical infrastructure. So I'd urge you to think of, as you're looking at this from a company perspective, to think of that about these cars and trucks and its technology as also being critical infrastructure that we will need to ensure that we can protect. Because I think it offers a tremendous step forward on so many areas and for so much safety and for military mobility that is using some of these common transport hubs. But you need to ensure that you answer that piece. What happens if?
Well, Jonathan, I think the auto industry has a story to tell there.
We have a great
on cybersecurity and how it relates to intelligent transportation systems. So maybe build on what Robin laid out.
Yeah, no, we have a great story. It's a work in progress, but we've come a long way. I know Tom in the audience has been part of this as well. The auto industry stood up a Auto ISAC, Information Sharing and Analysis Center. And it was created by the Clinton administration for critical infrastructure protection industries. And we decided we're not technically one, but we're close to enough, like you described. We consider ourselves a critical infrastructure industry. So I think we started doing this in 2013 or 14. I think it stood up in 15. It was fairly small, few OEMs, because you had to build the trust of sharing intelligence with each other of threats. So we have there's an operations center. We did it with Booz Allen. We have an operations center that looks out for threats on the deep and dark web, and there's meetings where we share those threats, and the companies share certain threats. It's become very successful. I think there's maybe 60 members now, 60 or so members of the Auto ISAC. It's become one of the models for other industries to do that. So GM played a big role in creating that Auto ISAC. Our head of cyber and our head of product safety were two of the founders of that and chair people, and continue to be co-chair of that organization. But it is unique in the technically non-critical infrastructure protection industry to have an ISAC. So we're hoping that our not only our membership increases and spreads, and information sharing and intelligence sharing increases, but we hope other industries do something similar because of the threats you mentioned.
Yeah, so it's a building block upon which you can now add V2X
Right.
and alert systems and those types of things, because you've got this sharing center.
Yep.
So, Ram, I want to come back to V2X for specifically. So we get past the alerts. Now let's talk about this low latency, always on communication between vehicles. So what are the benefits? You know, as you look at it from Harman's perspective, how would you describe the benefits of that type of technology to the public?
Look at some of the challenges that we face if those were not to exist today, right? For example, a harsh braking condition, or not being able to see a corner, right? And what's actually a traffic that's right around the corner, and things that we can actually see through now because of the presence of a CV2X or a V2X-like technology, right? These are fundamental to the success of some of these low latency communication-based use cases and scenarios. Like, for example, when you are in an urban terrain and you have 3D maps that need to penetrate, and you have to still make sense out of, okay, what is really the case at a certain point in time, and how do we communicate that into all the other vehicles around an intersection and so on. That's kind of like one. Harsh braking in some kind of a freeway-like scenario, do not pass. And these are kind of like some use cases and benefits of what low latency can bring in. And these are things that will absolutely require a V2X technology, right? I mean, you can alert some of these things in different ways, but then can that really meet the kind of latency criteria that is needed for systems to action upon? Definitely we need the V2X in that scenario.
Mm-hmm. And when you talk about those use cases, I mean, I think I've seen some data, I think from the National Highway Traffic Safety Administration that suggests that fully deployed, this could have significant impact on reducing highway fatalities and crashes.
Absolutely.
Right?
Absolutely.
Yeah.
And that is definitely the biggest benefit, right? I mean, for bringing down the road fatalities, also the vulnerable road user, right? And while we can, as I said, we can still start small, but then if you want a world where we literally can reduce and bring that down to zero, then you're really looking at a V2X-like technology that can come in and save lives. Absolutely.
Right. And so, Mark, what I hear Ram saying is that to get to that truly low latency, sort of 10 times a second communication between vehicles that can be actionable, which I interpret to mean you can have your crash avoidance system actually react soon enough to avoid the crash. Where do we need to be from a 5G perspective? Are we there yet? How is 5G developing in this country? And what does the regulatory framework need to look like if it's not ready today?
No, great question. And let me just make one comment on cyber before we get into this, which is...
Oh, I'm sorry, please.
No, just...
You should all be willing and able to challenge each other and discuss anything that's raised.
No, I think it's a
We're
great...
not shy.
No,
Yes.
it's a great point. And I just, is from the Asian perspective, a Korean perspective, this is an issue that's been top of mind for a long, long time in South Korea, right? The South Koreans have been highly... Well, let's put it this way, on the front lines of cyber attacks that have civil implications. Second, there's a military component, 30,000 U.S. troops, the most, I would argue, the most advanced combined integrated command between U.S. and the South Korean militaries. And in that context, that's where Samsung sits, right? So it's top of mind, it's in that context. So I think it's a really good flag, and it's something that South Korea has been focused on for quite some time. To your point about 5G in the U.S., I mean, look, what we would like to see is, let me back up and say, right now we've got 5G here, not yet enough to bring the giant leaps forward in speed and capacity, one. Two, at the risk of repeating a lot of what Jonathan and Ram outlined earlier, we've got access and affordability issues, right? We've got the $60 billion for deployment from the infrastructure law. That's critical to deploy that. Then to get into what some of the fellow panelists have said earlier, we need the FCC to increase the amount of spectrum available for vehicle communications, Congress, FCC to continue to bring more spectrum to commercial use, right? And then greater network and efficiency. We can get gains from that by reducing energy usage, what cuts down costs and has sustainability benefits. So, you can see this kind of package of the public sector, the private sector, R&D fused together to get at a lot of what you're asking.
You mentioned spectrum, and I think Jonathan mentioned the 5.9 gigahertz part of the spectrum where back those 20 years or so ago, Ram, that you mentioned, Congress saw fit to dedicate a certain amount of that real estate to the development of ITS, the development of intelligent transportation systems. And there have been some, shall we say, twists and turns along the way with regard to the development and the deployment of those technologies. But this idea about spectrum and having enough spectrum is interesting. Certain other countries have dedicated more spectrum to intelligent transportation systems and to V2X than we have. And in fact, it would seem to me we might be reducing the amount of spectrum available to ITS. Is that the case? And if it is, where do we find this extra spectrum that we're going to need? It seems to me more spectrum, more safety, right? More spectrum, more use cases. Is that right?
Absolutely. So in fact, I think we had to pause and look back on why this has happened and why is this actually happening, right? And would this continue happening as well, right? Because if we have done 20 plus years of research in this, and we have come through transitions from, say, the DSRC to the cellular V2X, and FCC actually also followed some of those recommendations to actually allocate a 45 megahertz for CV2X. And then finally, in the last 3 years, they decided to pause it and offer a temporary use for an alternate technology. It's because of this delay, right? And this delay has another effect on the deployment, more so from the infrastructure angle, but also the car makers are now caught on what to do in this situation. Do we plant cars with these technologies, or do you really push that out? And even if you succeed in bringing a solution and a closure to this topic, the cars with these technologies will still take a long time for them to show up. So it is why I think it's important for building that critical mass as soon as possible, and in parallel, continue to drive through the FCC to continue having that the bandwidth and the frequency allocation maintained for driving this V2X, and have that kind of a roadmap for how do we start small today? Because if you don't have the critical mass, if you don't create that necessary pull, and the delays continue occurring, then industry-wide you're going to see this, this challenge. And FCC is always constantly juggling with their priorities as well, right? So if it becomes like a delay is causing this challenge in the form of prioritization, they are making that call in that way. So I think we have to look at it from multiple angles. I would still say start small, aim big, and then drive it through the right structures and policies as well.
Jonathan, do you agree with that? I mean, what does General Motors, what do automakers need to deploy this technology?
Yeah, I agree. That we have such a long product cycle, and that we do so much testing to make sure everything's as safe as possible. So we do need, one of the things we talked about before this, we need the FCC sitting on all these CV2X waivers. So we need the FCC. I'm not sure where they'll find extra spectrum. I'm not sure when they're going to finish these FCC waivers. So there's a lot of blockades and obstacles for us to figure out what technologies can be deployed. And then to the point of the product cycle, it takes us X amount of years to test it and put it on the road to make sure it's safe. So we have a long way to go. We're looking at 5G with our Cruise Origin, our AV company out of San Francisco. But to that stepstone type of method, we need that to proliferate in order to make it safe for everyone. So if we have 5G in the Cruise Origin, which is our autonomous shuttle that we're already producing and internally and testing, we need to talk to other cars with 5G to make sure that, and to the vulnerable road user, whether it's from a smart watch or a phone or whatever it might be. We need that to proliferate so we could say, hey, you're in danger for X reason. So to answer your question, we need some regulatory certainty. We need a direction. We need a path from the government to tell us, hey, this is the direction we're going. But we also need that regulatory certainty to be technology neutral. We need some guardrails, and then we need to figure out how to develop that technology the best way we can and let the best technologies win in the marketplace and make it safe for everybody, not just GM cars, but everything, all OEMs.
I hear a recurring theme at technology roadmap, clarity. Can I take some questions from the audience? There are a lot of people sitting here, and I know there are people looking out at us from across the world. I'm not sure how many questions I could take from that platform, but I see a hand raised here in the room. Yes, sir.
Think about the highways, just leaving Washington, going to northern Virginia. What percentage of, in a local theater, what percentage of cars need to be smart cars before you can increase the capacity of the highways to take a lot more cars? And what kind of increase could you possibly get percentage-wise if you had enough smart cars in
So
a
this is-
particular theater?
This is a great question. If just the microphone came late to the questioner, but the question, and to sum up briefly, is sort of what's the network effect, right? Like how many cars do you need on the roads in order to realize the safety and mobility benefits of this technology? Is that
Increase throughput.
and one benefit of which is increased throughput? Who wants? Ram, you want to take a crack?
Sure.
At that?
Again, once again, I would say it's the debate between building smart cars versus making cars smarter, right? And if I look at it, I would actually start with the latter, to kind of see how do we solve this problem for today. And you said, okay, there are significant cars out there that may not have that kind of capability, but can that still become smarter and enjoy the benefits of what these smart cars are built to do and make and deliver? And I think if we can solve that problem, then naturally we are able to start small with the cars of today and then connect them to the smart cars, which will have these additional technologies and capabilities. It's hard to put a percentage and say that, okay, if I just build in, say, a 20% of the smart cars, they still would drive a greater amount of insights and abilities. I would definitely urge on addressing the problem for the greater mass that don't have this technology as well. So look for means to drive that value. And that's where looking through the lens of 4G and 5G, and 4G for sure, and most of the cars will have one form or the other to penetrate, and how these alerts and information can be rather informational in nature today before they become actionable. And that's when the smart cars are going to action them. But start with information, get to the mode of actioning the same thing.
Jonathan or Mark, Robin, anybody want to add anything to that answer?
No, I actually love the idea of moving it to action
Yes.
gradually, because I think there will be a certain amount of user adaptation necessary.
Yeah, I would agree. Jonathan? Anything?
I would just echo what was said, and I don't know what kind of number that is or percentage it would be, but I think that the differentiation between smart cars and a car that's smart is very smart. And a lot of these technologies we're working on already. We have OnStar, which started 26 years ago already, just over 25 years ago. Super Cruise, we're going into Ultra Cruise, which is the partially self-driving system that we have. And all those systems, it's an iterative effect to get all these safety benefits. But I think there is a step process, like you're saying.
Yeah, and if I were to just give numerical latency-based data, the V2X can cut it down to like 20 and 10 milliseconds. In 5G, that is backed on an edge-based computing, we are able to see that the latencies are coming down to somewhere around 30s and 40s. And then backed on a 4G network, it can be anywhere from 50 milliseconds to around 200 milliseconds. So do all the services require 10 milliseconds? Do all the services can tolerate, say, what percentage of those services can tolerate a 40 millisecond versus what can work on 200? And actually, if you look at the wide variety of applications, they can scale. So you can really bring an immense amount of value even today, which can tolerate a 200 odd milliseconds.
Terrific. There's another question. Yes.
Yes, I thank everyone for taking a broad view of the infrastructure and the ecosystem it's going to take to make this work. Because the technology is this much, and all the effort around the ecosystem is what it really comes to need to do all this. But I would bring up a couple points. One is the source of the technology is the 5G chipset. That's the source, and that's thankfully the United States has a leadership in it, and we're using this today in rail technology communications. The things you're talking about, we have much less restrictions on implementing them on trains as you do in cars. And it's a subset of V2X, but it is out there working. It's going to be launched here in America on 5G in this 2023, and in Europe and many other places. And taking advantage of everything that you're talking about is going to be deployed. So I would encourage everyone to keep an ear out to that area, and also in the standards, as you said, leaders and followers. This same thing happened in 1990s with voice over the internet. I went through all this, and it was a massive change and a massive ecosystem it took to do that. So I think you're on the right track, and to just listen to everybody that's talking in all the different areas would be very useful. Thank you.
Perfect. Thank you. Any reactions to that? I think there's a lot in there. One of which is looking at what's happening in rail. The positive train control, I think it's called. The idea that this similar technology, right, with similar challenges, right, and availability of spectrum, for example, right, as well. Any comments about the statement just made?
If you go back to the national security comment, I think you could look at that in the competition, the international competition element of it. If you look at it with AVs, for instance, America needs to lead. The government needs to come up with a policy, legislation, and then regulation with FMVSS that allows us to deploy. It's the same thing here. There's other countries, China, Europe, Germany, France, that are doing this before us, and it really is a matter of economic national security. And we see what's happening all over the world, and we need to do it here. We're deploying in Dubai, our cruise origin, partially because we can, and we need to say that about America.
Great comment. I think we might be at the end of our time here. I'm going to ask for one quick takeaway. I'm going to go from my left, from Jonathan all the way around to Robin. Your last quick takeaway from this discussion. Jonathan.
I think as you see, there's so many different ingredients and elements, from technology to policy to all kinds of different companies and products. I think we're all want to get to the same place, and more conversations like this with the right people and getting that message to regulators and legislators could change the future.
Thank you, Jonathan. Thank you for being here. Ram?
In terms of adoption, right, so there are part of technologies that are already in place, like 5G infrastructure growth in this country is, I would say, pretty much on par with other regions, right? But when it comes to some of the other site technologies like V2X, I think we are behind. And I think it's important to understand how do we start small, scale in a timely manner, and really work towards that that world that we are trying to paint through the active AV policy and frameworks and all of that.
Ram, thanks for your insights. Mark?
Just a couple of closing thoughts. One, it's an ecosystem, right? Physical and the technological fused together, and I think that's what the Biden administration is trying to get at, right, in some of their larger initiatives. Second, the importance of friends, partners, allies in this, right? I think that's another piece that is just, it's a strength of the United States, Germany, and the Asian allies working together. And that gets to the third point, rule setting, standard setting, which I think Robin's points were just spot on, where they're going to have this basically coalition working to set standards, or we're going to take standards, and I'd much rather be in the position of setting standards across a broad range of technologies, biologics, electric batteries, as Congresswoman Dingell outlined, electric vehicles, battery technology, semiconductors, 5G, all of that coming together. Thank you.
Amen. Thank you, Mark. Robin, last word goes to you.
Oh, the pressure's on. Let's do this with our allies and partners. The importance of dialogue as we go forward, because that is how we will get to the place that we want to be, where we are really setting the standard and setting the pace. Thank you.
Robin, thank you so much, and thank you for your leadership. Thanks all of you for being here, whether you're here in the room or on the virtual platform. Fascinating conversation. We could go all night. Thank you again to the panelists. Very well done. And thank you, of course, to Harman International and for the Wilson Center for bringing us together. Thank you so much for being here.